Here we got a circuit of 3 parallel capacitors. The first capacitor has a capacitance of 0.10 farad, next one 0.08 farad, and the last one 0.05 farad. Right now the system is disconnected, but when we connect the switch, we connect it to a supply voltage of 12 volts. Basically, we have two formulas for capacitors to calculate the charge, and it is either the current multiplied by time or the voltage multiplied by the capacitance. For this circuit, we want to find out, can we change these 3 capacitors so we only have one capacitor, and what should the value be if we have to find an equivalent for these 3 capacitors, so simplifying the circuit. And we know that the total charge for all the 3 capacitors, that must be the sum, and we call that QP for parallel. And we can see up here in the formula, instead of the charge, we can say the voltage times the capacitance. So the supply voltage multiplied by the total capacitance of all the 3 capacitors, Cp, must be the voltage across capacitor number 1, multiplied by the capacitance for number 1, and so on for number 2 and 3, and 4, 5, 6, and so on if we got more than 3 capacitors. In a parallel circuit, we also know that the voltage is the same. So the voltage up here are the same, so we just can divide by the voltage, and we got only the parallel capacitor is the sum of all the capacitance in a parallel circuit. And it looks like the formula for serially connected resistors, so it is quite easy to find a similar capacitor for all these 3 capacitors. We only have to add the capacitance for all the capacitors. We can also see in a parallel circuit that since the voltage is the same, the charge depends directly of the capacitance of the capacitor. So the higher capacitance, the higher charge. We can try to connect the system, and we can see here the first capacitor has a high charge and many positive and negative on the plates. The next one is a little bit lower, and the last one of 0.05 farad is lower again. So that's when we connect capacitor in parallel. To simplify the circuit, we just have to add the capacitance together.